Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. We are given two quantities. The quantity A is x to the power n multiplied by y to the power n, and quantity B is xy whole to the power n, and n is greater than 0. And we have to determine the relationship between quantity A and quantity B. So if you look at quantity A is x to the power n multiplied by y to the power n, under quantity B is xy whole to the power n. And it may seem fairly obvious that these two are equal. And they are equal for most cases. But in order to have the correct choice, we have to basically be sure that these two quantities, x to the power n multiplied by y to the power n, is equal to xy whole to the power n in all cases, all possible cases as the problem allows. And in this case, the only constraint that we are given is n has to be greater than 0. Now, if we can show that the relationship does not hold for any one set of x, y, and n, any one set of values of x, y, and n, as long as those values are allowed, then that's sufficient for us to be able to conclude that the relationship cannot be determined from the information given. So the normal response for this question and the average response would be these two are equal, because it's so obvious. It seems like, why shouldn't they be equal, right? But we have to consider, this special case when x is negative, so x is negative 1, y is negative 1, and n is, I have taken n as 0.5, so n is still greater than 0, right? So there's nothing that specifies that n has to be an integer or whole number. So n can be any number greater than 0, so I picked 0.5. And then if you do x to the power n, y to the power n, this becomes minus 1 whole to the power 0.5 multiplied by minus 1 whole to the power 0.5. And then if you just add up the indices, we have minus 1 whole to the power 0.5 plus 0.5 is 1, so minus 1 whole to the power 1, which is minus 1. Now, this is a little bit controversial the way I arrived at this, because individually minus 1 whole to the power 0.5, it's an imaginary number, right? But you take the product of two imaginary numbers, and then the result is a real number, minus 1 in this case. Whereas if we do this xy whole to the power n for these set of values of x, y, and n, the product that we get within parentheses xy is minus 1 multiplied by minus 1, which comes to 1, and then 1 to the power 0.5, that's simply 1. So in this case, we have a difference in values of x to the power n multiplied by y to the power n and xy whole to the power n. However, the easier case, of course, there are many such cases. Depending on what the values of x, y, and n are, you can probably pick many other values to arrive at this simple set of values, x equal to minus 1, y equal to minus 1, n equal to 1. You can show quite easily for these cases that x to the power n, y to the power n will be equal to 1, and xy whole to the power n will be also equal to 1. So for one set of values of x, y, and n, we are having a relationship which shows that this is equal. For another set of values, we're having a relationship that shows that these two quantities are not equal. So the obvious choice in this case would be then option D, the relationship cannot be determined from the information given.